Hello everyone. This is an actual short lesson video lecture. Some extra ones, not the regular lectures. This is about number 14, section 6.4, arc length section. I found that many students have struggled with number 11. Now that you have a full solution of number 11, you can go over. So I decided to cover similar problems, even though I didn't assign this one as a homework. Instead of going over the same problem, I think it would be better to cover similar problems so that you have two similar problems to study with. Okay? This is very important and very popular problem for quizzes and exams. Okay, so here the problem asks you to find the arc length, exact length of the graph of y equals x to the third over 3 plus 1 over 4x, right? And your x is between 1 and 2. So your arc length is obtained by doing this 1 plus y prime squared. So there are two different kinds. When you're given a parametric equation, you get x prime of t squared, y prime of t squared square root, and integrate. But if your graph is given by as a y equals some function of x, then you have to integrate this square root of 1 plus y prime of x. Now, over here, so keep this one in mind. Y prime is x squared. This is 1 over 4 times derivative of x to the negative 1. That would be minus x to the negative 2, right? Or you can write it x squared 1 over x squared. Okay? So let's consider this expression. The expression inside the square root in the integration of arc length. So, using perfect square formula, a minus b squared is a squared minus 2ab plus b squared. A squared would be x to the 4. Minus 2 times this times this. Plus square of b, 16. Here is the key step. X squared cancel 2 1, so minus 1 half. So I can write this one as x squared squared 1 over 4 x squared squared. So this is a result from perfect square of this. Now, this one was chosen carefully so that this plus 1 will change minus 1 half to positive 1 half, right? And this is the key step, 1 half. Right? This is the most important step. So, how did you get this constant? By having cancellation, right? I can rewrite this one as 2 times x times 1 over 4x squared plus 1 over 4x squared squared. See? X squared cancel, 2 and 4 cancel 1 half, right? Just like you got minus 1 half from here, you can get positive 1 half from here with positive. Right? This plus 1 kind of switched from negative 1 half to positive 1 half so that it becomes perfect square with positive sign. Right? That's the key. And you will see exactly the same thing happening in number 11 too. All right? So, when you have now arc length from 1 to 2, 1 to 2, square root of 1 plus y prime squared dx That would be square root of this perfect square. Inside one is part. Square root cancel, right? So you will have 1 to 2 x squared, 1 over 4 x to the negative 2 power. So after that, you can finish the problem, right? 1/3 of x to the third, 1 to 2. Adding 1 will be negative 1. Its reciprocal is negative 1. So negative 1/4, 1 over x, 1 to 2. Okay? So you can finish from there. 1/3, 2 to the third, 8, 1 to the third, 1, minus 1/4, 2, 1/2, minus 1. So this is 7 over 3. This is negative 1/2. Negative cancel, positive 1 over 8. So 24. 56 plus 3, right? So 59 over 24. Anyway, these are just the, this is the key step, right? And this 1 and this coefficient was arranged in such a way that it flipped the switch, right? That was the key in this problem, just like in number 11. And this is very famous problems in this section, okay? So I hope that this one clarifies the struggles, the questions you had in the solution of 11. Now you have to go back to, not only go over this one, also go back to the solution for number 11, okay? All right, we'll see you next time.